Hello everybody. This is our first video for the upcoming unit, which is measurement in geometry. We are going to focus on angle relationships in a triangle. A lot of this will be a review from grade 7 and 8. Let's start with the straight line. You might have mentioned in grade 8 that a straight line, if you measure it from one end to another, so let's say from here all the way to the other side, it measures 180 degrees. And that will be a very useful concept when we're doing a lot of these problems. So try to remember that a straight line is 180 degrees. How it applies in some questions is that we might have two or more angles splitting that 180 degree angle, and that creates a relationship such as this, where x plus y is equal to 180 degrees. So if you were to know what one of the angles is, let's say x is 30 degrees, what we can do is we can calculate the other missing angle simply by subtracting 180 degrees minus 30 degrees. And in this case, we would know that the leftover, the remaining angle y is 150 degrees. So this is how it's going to become useful. Now, this doesn't only work for two angles. You might have a situation where you might have three angles. So let's say there is an additional angle here, something like that. And this angle is Z. In this case, all three of them together would add up to 180 degrees. So that creates a relationship, something like this: x plus y plus z is equal to 180 degrees. So depending on what kind of question you have, always remember that a straight line is 180 degrees. The next concept is the triangle, angles in a triangle. In this case, you can see that we have a triangle with interior angles x, y, and z. So we're referring to this angle, and this angle. And you would have heard it before that together they also add up to 180 degrees. If you look at this demonstration, you might see that there's an angle A, B, and C. And if we were to take the angles and stack them next to each other, you will see that they form a straight line, which is 180 degrees. There you go. It doesn't matter what kind of triangle I have. I can change the triangle, and you can see that it also changes the relationship between interior angles A, B, and C, but they always add up 180 degrees. If you maybe know two of those three angles, it is possible to calculate the third one. So what I mean by that is, let's say that our x angle is 30 degrees, and our y angle might be, let's say, 50 degrees. We can calculate our angle z just by solving the equation. So if we substitute our x and we put 30 instead, plus 50 instead of y, what we have is a simple equation with one variable, which is z in this case. What we can do is just solve these equations first by adding the like terms on the left side, which is 30 and 50. That gives us 80 degrees plus z equals 180. And then we can subtract 80 from both sides, and we would get that z is 100 degrees. And this is how we're going to apply the relationship of internal angles in a triangle. So again, they add up to 180 degrees. It's very similar to a straight line. Moving on, let's say we have a situation where we have two lines intersecting. We have an intersection point, which would be a point right here. And we can describe a relationship between angles directly across from the intersection points. It means if I have an angle A here, directly opposite angle will also be the same as that original angle. So this is also angle A. Same goes for angle B and angle B right across from the intersection. How that's going to be used is that, let's say, we have angle A is 30 degrees. Right away, based on this relationship of opposite angles, I know that the opposite angle right across the intersection point is also 30 degrees. And that's really how we're going to use it. If we were to change it, let's say our angle B on this side is 100 degrees. I know right away that the angle on the other side is also going to be 100 degrees. Very useful tool as well. The next set refers to relationships between parallel lines, and then a transversal. So parallel lines, you probably remember from grade 7 or 8, are lines that never cross. So they're going kind of side by side, and they will never intersect at any point in the future in any direction. Transversal is just a line, a straight line, that intersects those parallel lines. So in this case, if you look, we have two parallel lines, which we demonstrate with these arrows. We can know that these two are parallel lines, and you can see that all the way along. These are also parallel and also parallel. And then we have this transversal. So this is our transversal. You can see it right there. When we have a situation like this, we can describe certain relationships between angles created. So our first one is alternate angles. Alternate angles are these angles here, this one and this one. And the rule is that those two angles are the same in size. So if this one is 40 degrees, then the other one is going to be 40 degrees as well. This is also called a Z pattern, simply because it creates a little bit of a Z. There we go. So that is the alternate angles or Z pattern. The next one that is very similar is corresponding angles, and corresponding angles are, let me pick a different color, are this angle and this angle right here, and they are also equal, just like in Z pattern. In this pattern, these angles are also equal. So if this is 30, this is also going to be 30 degrees. This is also called the F pattern because it creates a bit of an F. There we go. Last one is cointerior angles, and cointerior angles you can see are this one and this one here, and this rule is a little bit different from the Z and F pattern. Cointerior angles actually add up to 180 degrees. So that means if I have this angle here is 80 degrees, then this one here would have to be 100 because together it will add up to 180 degrees. There we go. And we will be using these relationships we will use these relationships anytime we have parallel lines in a transversal going through those parallel lines. All right, that brings us on to the next point. We already talked about interior angles over triangles, so that's pretty straightforward. Again, interior angles are these ones here, inside. What we didn't talk about is exterior angles of a triangle. And in this case, exterior angles are drawn by extending the sides of the triangles in a certain direction. So you can notice that we have extended these sides out in almost a counterclockwise direction. And that helps us create the exterior angles. In this case, we have exterior angle X exterior angle Y, and exterior angle Z. Now the rule is that if we add up these exterior angles, X, Y, and Z, they add up to 360 degrees. So interior angles of a triangle add up to 180, and that was the rule up here. Exterior add up to 360. Very important to remember. There is another rule, and this rule connects the exterior angles with the interior angles. And how it does that? It says that if I add up two interior angles, like this X and Y, they are equal to the sum of the opposite exterior angle. So opposite means it's just across from the two interior angles. So in this case, the two interior angle add up to this exterior angle. That will become very useful because if we know the two interior angles, this is 30 degrees and this is 50 degrees, we will know right away that this exterior angle is 30 plus 50, which is 80 degrees. And again, that will come in many different shapes as we do the problems in class. All right. If at any point you need to stop the video and maybe rewatch it just so you absorb the information, you can do so. I will be moving on just to keep the video shorter. So here's an example of a question. It says find a measurement of the exterior angles of a triangle A, B, and C. So this is how we usually put a symbol for a triangle ABC. A, B, and C are vertices of the triangle. So you can see that there's the A, there's the B, and there's a C. And you can also notice that we have our sides of the triangle extended to create exterior angles. Now, we can probably go and calculate things right away, but we are going to go over how you label and how you name certain angles. If you just have angles A, B, and C, all right, there was a little bit of an interruption to the video, but to go back to this question, we will go over and name these certain angles that we can define in a triangle. So here are some questions that will guide us. We will look at angle ACB, BAB, and then we can also name the three exterior angles. So angle ACB, it describes the angle that starts at A, goes to B, and then goes to C. So really, we're describing this angle right here. It is a 50-degree angle. So angle ACB equal to 50 degrees. So that is a format that you might sometimes see for describing angles or naming angles. If we look at the other angle, which is DAB, we're going to start at D. So we're going to start D and go to A and then to B. And the angle created by the lines that we just connected is this exterior angle. And at this point, we don't have the value of that angle, but we will calculate it. And then if we want to name the exterior angles, we have three angles. So DAB was one of them. So that is one of the exterior angles. The next one will be this one. Starts from E, B, and C. So that is this exterior angle. And the next one would be from F to C and to A. There we go. And that would be this exterior angle. So those are the three exterior angles. Now, we can actually go ahead and do some calculations. So the easiest exterior angle that we can calculate is this one, DAB. So it's this exterior angle, and we are going to use the straight line rule. We know that this line, the C line, let's say, is 180 degrees. What we have here is we have two angles that split that 180 degrees. One of them is 85 and the other one is our exterior angle. So if we want to calculate our angle DAB, all we have to do is subtract 180 minus 85, which is going to give us 95 degrees for our exterior angle. There we go. For our next exterior angle, we can also use the same rule. So in this case, I will use a straight line AE, and we know that it's 180 degrees from one side to the other side of the straight line. And in this case, we have the 180 degree angle split into two angles again. One of them is 50, and the other one is our exterior angle, B, B, and C. We have to do pretty much the same thing as we did before. We're going to subtract 50 from 180. And in this case, we will get that it is not 150, what I was going to write, but 130. There you go. We have one more angle left, which is angle FCA. However, we don't have an internal angle in here, so we don't have an angle ACB. We could get it, but we can use the external angle rule. And if you remember that if we add up the three external angles, they all add up to 360 degrees. So angle DAB plus angle EBC plus angle FCA equals 360 degrees. We do know two out of those three angles. We know that DAB is 95 degrees. We know that EBC is 130 degrees. And we need to find angle FCA. There we go. What we have here is another equation. We are going to group these two together. And that adds up to 225 degrees plus angle FCA. There we go. And we are going to solve for angle FCA just by simply subtracting 225 from both sides. Again, if you remember, this is nullified. Get angle FCA and 60 minus 55 is 35. And there we go. Those are our three external angles. Moving on to our next question, we have an example of an equilateral triangle. If you remember from grade 8, an equilateral triangle has same three angles, interior angles, and those three angles add up to 180 degrees. So if we divide 180 degrees into three equal pieces, you will get each one of those angles is 60 degrees. So this is 60, this one is 60, and this one is 60. And this is always the same. It doesn't matter how big the equilateral triangle is, how long the sides are, the angles are always going to be 60 degrees. So sometimes you might see a triangle that doesn't have any angles labeled or no measurements given, but as soon as you see these lines, you will know that the sides are the same, which makes this an equilateral triangle, and therefore each angle is going to be 60 degrees. Our next triangle that we are going to look at is isosceles triangle. Isosceles triangle is similar to equilateral triangle, but in this case only two sides are the same. Two sides, and you can see that by those two little lines. And as a result, we have two angles that are the same inside an isosceles triangle. And those two angles are opposite or across from the two equal sides. So if this one, this is 70 degrees, it's across from that side, then the angle across from this one, which is x in this case, will also be 70 degrees. So this is also 70 degrees. That means if we really wanted to find out all the angles inside the isosceles triangle, we can find y simply by subtracting the two 70-degree angles from 180 degrees, which is the sum of all angles in a triangle. That still applies here, whether it's equilateral or isosceles. So in this case, we get that it is y is 40 degrees. There you go. And our last question, we will find the measurement of angle ABC. And if you remember, the angle ABC is created by lines from A to B and from B to C, which means that we are referring to angle X, really. We have two angles. One is the angle 45, it's an interior angle. And then we also have an exterior angle, which is 110 degrees. Now, if you notice, the external angle, in this case, it's right across from the two interior angles. So we can apply the external angle theorem, and we know that the sum of the two interior angles, so angle CAB plus angle ABC add up to angle DCA. The good thing is that we have 2 out of 3 angles. So CAB is 45 degrees. We are looking for angle ABC, which in this case is X, and angle DCA is 110 degrees. There we go. And once again, we have an equation that we can solve. We're going to subtract 45 degrees from each side. That's 0. And we get that the other internal angle is 65 degrees. And there we go. That is the lesson. There is some questions that we are going to cover in class. If you have any questions after the video, write them down with the notes and ask me in class tomorrow. See you tomorrow.